बच्चों, in this video we will try to study about some terms related to the projectile motion, like how much height it will cover, how much distance, horizontal distance will it cover, and up to what time, how much time it will remain in the air after the projection. So we will calculate first the height attained by the projectile. Number one, we will try to calculate height of the projectile. Height of the projectile means अगर हम पत्थर या कोई चीज इस तरह से फेंकते हैं तो कितनी हाइट तक जाएगा वो, जैसे यहाँ पे h दिख रहा है. What will be this height? Up to what height it will go? Number two, time of flight. Time of flight. Time of flight of the projectile means the time interval up to which the projected body is in air. And number three, horizontal range. Horizontal range. Horizontal range R. That is how much horizontal distance it covers from the point of projection. We have thrown the stone from this point and it hits the ground after traveling along this path at this position, say at this point P. So this OP is the horizontal range. So first come to height of the projectile. Height attained by the projectile. Suppose a body is thrown with velocity u making angle theta with the horizontal, and it goes up to height h and then it returns back. So this vertical height is covered by vertical velocity. There is no role of this horizontal velocity in covering the vertical height. ये दो वेलोसिटी जो हैं, ये दो वेलोसिटी, हॉरिजॉन्टल वेलोसिटी और वर्टिकल वेलोसिटी, ये दोनों बिल्कुल इंडिपेंडेंट हैं. ये दोनों एक दूसरे के काम में बिल्कुल कोई इंटरफियर नहीं करती हैं. हॉरिजॉन्टल वेलोसिटी से सिर्फ हॉरिजॉन्टल डिस्टेंस कवर होती है और इस वर्टिकल वेलोसिटी से वर्टिकल डिस्टेंस कवर होती है. आपने ये भी पढ़ा है कि हॉरिजॉन्टल वेलोसिटी की जो वैल्यू है वो पूरी जर्नी में कांस्टेंट रहती है. क्यों? क्योंकि इसके अपोजिशन में कोई नहीं है, कोई इसको अपोज नहीं कर रहा है. अगर एयर फ्रिक्शन को हम नेग्लेक्ट कर दें तो कोई ऐसी चीज नहीं है जो इस वेलोसिटी को अपोज करे, इसकी वैल्यू को कम करे. इसलिए हॉरिजॉन्टल वेलोसिटी की वैल्यू कांस्टेंट रहती है. लेकिन वर्टिकल वेलोसिटी जब स्टोन ऊपर जा रहा है तो एक्सेलरेशन ड्यू टू ग्रेविटी जी की वजह से इसकी वैल्यू कम होती जाती है. इट गोज ऑन डिक्रीजिंग एंड एट द हाईएस्ट पॉइंट it becomes 0. So if we apply to find this height, we apply third equation of motion. The initial vertical velocity of the initial vertical velocity of the projectile is equal to u sin theta. Final vertical velocity of the projectile at the top is equal to 0. Final velocity is 0. G is acting downward. Acceleration due to gravity is acting downward. So from third equation of motion, third equation of motion क्या है? b square is equal to u square minus 2gh. Here in this case g is acting downward and the stone is going up, so g will be negative. Put the values. Final velocity. Final velocity is 0. Initial velocity is how much? U sine theta. U sine theta whole square minus 2gh. That is 0 is equal to u square sine square theta minus 2gh. Bring this 2gh to this side. This 2gh is equal to u square sine square theta. Therefore, h is equal to u square sine square theta by 2g. This is the height attained by a projectile which is thrown with velocity u, making angle theta with the horizontal. The maximum height which it will cover h is equal to u square sine square theta by 2g. Clear? Now we will calculate the time of flight. Time taken by the projectile till it is in air. So how can you calculate this time? The time up to which the projected body is in air is known as time of flight. फेंकने के बाद और जाके टकराती है, जब तक वो हवा में रहती है उस टाइम को हम टाइम ऑफ फ्लाइट कहते हैं. तो फॉर दिस the initial vertical velocity is u sine theta, and here when it strikes the surface, again the velocity is u, and it has here the component at this point is u cos theta, that is the horizontal component, and the vertical component is u sin theta. But this will be negative because initially it was u sin theta in upward direction, now it is in downward direction, so it will be negative. Initial velocity is u sin theta, and final velocity when it hits the ground is vertical velocity downward direction. Here it is minus u sin theta. So what will be the time? We will calculate that time by using the first equation of motion. Use the first equation of motion to find this. Time of flight. Initial vertical velocity. Initial vertical velocity. Initial vertical velocity with which the body was thrown, जिससे इसको फेंका गया था, कितना थी u sin theta, and final vertical velocity of the body when it hits the ground. This will be equal to minus u sin theta. This is initial velocity when it is thrown in vertical direction, upward direction, and when it hits the ground, its velocity is minus u sin theta. So how much time it was in air? It is calculated by using the first equation of motion. So from first equation of motion, first equation of motion. From first equation of motion, first equation of V is equal to u minus gt. Here sign will be negative because initially the g is downward and velocity is upward direction. So V final velocity is minus u sin theta is equal to initial is u sin theta minus g, and time till it was in air is t. Now bring this gt to this side. Minus gt is transferred to this side, will be positive, and minus u sin theta will be transferred to that side. Here minus, it will become again positive to that side. So gt is equal to u sin theta plus u sin theta. u sin theta, 2u sin theta. That is the gt is equal to 2u sin theta. Therefore, t is equal to 2u sin theta by g. This is the total time till the stone was in air, and half of this time is the time when the stone will achieve the stone will attain the highest point. It will be equal to, this will be equal to t dash is equal to u sin theta by g. That is, in this time the stone will reach to the highest point, and in the same time it will come back to the ground. So the total time will be equal to 2u sin theta by g. So the time of flight, that is the time till the stone was in air, is equal to 2u sin theta by g. Clear? Now come to the horizontal distance covered. Third one is the horizontal distance covered by the projectile body. This horizontal distance is covered by the horizontal velocity. जैसा कि मैंने पहले बताया था कि horizontal velocity से horizontal distance cover होगी और vertical velocity से vertical distance. ये दोनों velocity independent होती हैं, एक दूसरे के वर्क में कोई interference नहीं होता. तो horizontal distance covered is the horizontal range. So horizontal range is equal to horizontal velocity into the time till which the body travels. The body travels up to how much time? That is equal to time of flight into time of flight. जब तक हवा में पत्थर है वो हॉरिजॉन्टल डिस्टेंस कवर कर रहा है, ऊपर भी जा रहा था फिर नीचे आ रहा था, लेकिन हमेशा वो हॉरिजॉन्टल डिस्टेंस में आगे बढ़ता जा रहा था. किस वेलोसिटी से? u cos थीटा से. तो हॉरिजॉन्टल डिस्टेंस जो आएगी वो आएगी हॉरिजॉन्टल वेलोसिटी मल्टीप्लाइड बाय द टाइम ऑफ फ्लाइट. व्हाट इज हॉरिजॉन्टल वेलोसिटी? Horizontal velocity is u cos theta, and the time of flight we have just calculated, it is equal to 2u sin theta by g. So this r is equal to u into u, this will be u square into 2 sin theta cos theta by g. In mathematics, you will study a formula in trigonometry, that is 2 sin theta cos theta is equal to sin 2 theta. This is equal to sin 2 theta. This is a formula you will study in math. So you just remember that 2 sin theta cos theta equals sin 2 theta. So replace this one. So we will get r is equal to u square sin 2 theta by g. This is the horizontal distance covered by the projectile. So what will be the maximum distance covered by projectile? The value of this horizontal range will be maximum when the value of this sin 2 theta is maximum. What is the maximum value of sin 2 theta? The maximum value of sin 2 theta is, in note you can write down here, note, r will be maximum when sin 2 theta is maximum. The horizontal range will be maximum when sin 2 theta is maximum. And the maximum value of sin 2 theta is 1. Maximum value of sin 2 theta is equal to 1. And you know that sin 90 is equal to 1. So you can write that Sin 2 theta is equal to sin 90. This implies that 2 theta is equal to 90 degree or theta is equal to 45 degree. It means if you want to throw a body for a longest distance for maximum horizontal range, then you have to throw the stone, that body, at 45 degree. If you want to hit a cricket ball for a longest distance, so you have to hit the cricket ball at angle of 45 degree with the horizontal. If you will throw the ball at 45 degree, it will go for a very long distance. The longest distance, the maximum horizontal range will be covered when you will throw the ball at 45 degree. One thing more, the horizontal range will be same for theta and 90 minus theta. Horizontal range is same for theta and 90 minus theta. आप थीटा पे फेंकें या 90 माइनस थीटा फेंकें, दोनों पर हॉरिजॉन्टल रेंज सेम आएगी. मतलब कि अगर आप 30 डिग्री फेंकें या 60 फेंकें, तो दोनों के लिए जो हॉरिजॉन्टल रेंज होगी वो क्या होगी, सेम होगी. क्योंकि यहाँ जो फार्मूला रेंज का है वो r इज इक्वल टू है u स्क्वायर साइन 2 थीटा बाई g. नाउ दिस इज फॉर थीटा, and if suppose you place here, in place of theta you put here 90 minus theta, then this is at theta angle, और फिर कैलकुलेट करिए at 90 minus theta. At 90 minus theta, r is equal to u square sin 2 90 minus theta by g, that is equal to u square sin 180 minus 2 theta by g, and you know that sin 180 minus 2 theta is sin 2 theta, so it becomes equal to u square sin 2 theta by g. That is r is same for theta as well as 90 minus theta. For example, suppose you throw a stone making angle 30 degree. This is 30 degree. So horizontal range is this much. And if suppose this is theta is equal to 30 degree. Now 90 minus theta means 90 minus 30 means 60 degree. Now another stone throw with the same velocity. This velocity is 0. Again the velocity is same. You will find that it hits at the same point. This is thrown at angle how much? This angle is 60 degree. The horizontal range is same for both angles. If you throw a stone at 15 degree, it will come here. This angle is 15, and if throw at 75 degree, it will come to the same point. This angle is 75. So it is theta is equal to 15 degree, and 90 minus 15, that is equal to 75 degree. So the horizontal distance will be same for complementary angles. If you throw the stone at theta or 90 minus theta, it will cover the same distance, same horizontal distance. Remember, while doing the numericals, take care whether the angle is given with the horizontal direction or vertical direction. Sometimes in question it is given that a stone is thrown making 30 degree with vertical, and the students directly apply these formulas. So the question will become wrong, because here the angle is not with the vertical angle is with the horizontal. So study the question carefully whether the angle is given with the horizontal or it is given with the vertical. Clear? Okay, we will solve some numerical based on these uh, terms, that is maximum height, time of flight and horizontal range in the next video. Till then, bye.